consortium, Horizon Europe, Horizon 2020 project. Today you will see and learn a little bit more about the context and challenges of the project from my side, then followed by Alessia Bardi on open science. What does it actually mean? We'll then listen to Julia Conforto, who will talk about the training and the gateway itself, when followed by Marcus, also from eThink, he will talk about EnerMaps, the data visualization tool, and do your little training and insights, when followed and finished then today by Pietro Zambelli, who's doing the calculation modules, one of the interesting parts within EnerMaps that helps you to resolve concrete questions. With that, I'll go to the next slide. So we can jump over to the next. So generally, when you look over data and you're looking for it, you find a lot of it. However, it's more like in the window on the screen that you can see there. It's a bit unstructured. It's everywhere, and it's not really clear to how to exploit this. What EnerMaps tries to do is, on the next slide, we'll try to figure out this mess of data, try to sort it out, try to help you find the KPIs, get out of the data the information that you're looking for, making the decision that helps you to move forward. Next slide. We have built EnerMaps on the lessons learned from the HotMaps 2020 project, H2020 project, that I think Marcus will also mention a bit more later on. We realized during this project already that there's a lot of data available, but it's generally unstructured, not in the way that you want it to be used in your tools. And then for the correct exploitation, once you have structured it, this data still requires a lot of metadata, time and know-how to be sure that you understand it correctly, so that you use it and exploit it in the best way. And when especially you're working, let's say, for a city, a country, or maybe even the European Commission, you want to have regular updates on the data, because it's nice to have last or a couple of years ago's data. You still want to have the next year and so on. So you will be confronted to the challenge of regular data updates that require often time and often bring you back to the first point, that data is unstructured again, and you need to do all the work again to reintroduce it. And especially also during this project, we discovered the legal challenge again. How can you reuse data? How can that be handled? That sounds already fine, always fine and easy. However, that challenge in the age of internet that is a lot faster remains a key challenge, because it's dependent on the license that people put on data. So what we derived from the lessons learned is that ideally you would like to have curated data sets, and that's also up to the audience to confirm us a little bit, so that once you start, you have some data sets that are available and quality checked, so that you know that you can trust them and build your research or business plan based on what you have found there. When we go on the next slide, I'll explain you a little further that, I mean, again, the data, the energy databases are often separated, so that the quality checks also among them gets quickly quite difficult. There are a lot of scientifics in the community, people in the community that do work with data, but once they do their study and publish it, it's difficult to get and not easy to find. And this is what we like to address. And in the next step, we'll look at the final, at the visualization analysis tools, because if you don't have those skills already yourself, it's sometimes difficult to learn on how to code and how to exploit this. So EnerMaps is trying to help you there. And the final point is, generally the data related know-how of target groups can be low, or which can be addressed by trainings like we try to do it today, and specific workshops on data related issues, and in our context of our project, of course, always energy related topics. Next slide. So when we talk about data in terms of EnerMaps, we generally try to refer to fair energy data, which means findable, accessible and interoperable and reusable data. So this is the key to work and be not limited by one of the different barriers that I already mentioned. Again, the reusable part can be quite quickly underestimated. Having licenses on data and having licenses that allow data to be reusable is really hard, as some of the quality data sets that we found were unfortunately excluded, linked to the last point. Data is more and more value, so people tend to restrict this point. On the open science part, Alessia will complete me afterwards, so I'll go to the next slide and not talk too much about what is the bigger concept behind it. Next, please. So EnerMaps is really addressing this open management, open data management tool, the data management and the accessibility in a large field. We see on the left side of the picture really different jobs that are looking for data and like to build their reasoning on data. We have, of course, the scientists. We have the public authorities. We have the engineers that really build the new energy system. We have the decision makers and the people that support them and that need to have this data, as well as the pure data analysts that are working in this field now. And we hope that they can use the EnerMaps gateway as a findable entry point for the energy community and build really their reasoning and their results based on the data that is available there. We are, with this offer, accelerating and facilitating the energy transition based on this quality and user-friendly digital platform for energy professionals in a large sense. I'll go to the next one, please. So just a glimpse on the consortium. We are a consortium of the following institutions: the CREM, where I'm working, EURAC Research in Italy, where you are, IDIAP in Martigny, Switzerland, as well. TU Wien, Open Air, eThink, and Revolve are the key members and the members of this consortium, and we're together building this platform. And as I already introduced, part of us are there really in person and could make it today. So we'll go to the next point. Well, I just quickly resume our objectives that we fixed and that we try to address with the platform that we have created here. So the centralize really the data sets in a user-friendly, accessible way, so that you can connect to it and work with the data that you find. That helps you improve the accessibility also of additional scientific data sets that you might not have found so far. You get the quality check for the curated data sets. So you have about 30 to 40 data sets that are up there that have been checked by experts on different levels of detail and compared to other existing data and chosen carefully so that there's really the best available data set on a European level available for you. And based on this offer, we hope to really increase the energy data knowledge and help you really in the trainings to actively work on that, so that we can accelerate and facilitate the energy transition. So from my part as the coordinator, this is basically already the resume. And now on how do we fulfill these objectives, I'll hand over to Alessia, unless you have already a question to me at this point. I'll be happy to answer. I'll also stick around for questions afterwards. So if not the case, please, Alessia.
Okay, so hi to everyone. Good afternoon. I'm Alessia Bardi. I'm a researcher in computer science and in the domain on the topic of scholarly communication. And I'm also member of the Open Air initiative, which is a no-profit organization for the support and promotion of open science practices in the scientific context. So next slide, please. So what is open science? It's the practice of science in such a way that the others can collaborate, contribute, and where every single piece of the research process is available under terms that enable their reuse, their redistribution, and reproduction. And these principles shouldn't only be applied in order to foster good and open research in academia, but also to foster innovation and bring the people closer to science and to research in general. So also thanks to the citizen science movement. Next slide, please. So the term open science implies a number of concepts. And as you can see here, it's like an umbrella term, which includes open access to publications, fair data, open source software, open peer review, and much more. So the basic idea is that with open science, we open as much as possible each step of the research activity. And this approach has been recognized as a crucial accelerator to reach the sustainable development goals that are set by the United Nations, and also to ensure a more transparent and inclusive research process. And in particular, it's worth to mention the UNESCO recommendation on open science, and you can find the link here, but you can also search it on Google, and it will be very easy to find if you want to know more. Next slide, please. But open science is not only about policies, it's also about technical infrastructures that can help with the adoption of the open science practices and with the tracking of the outputs of the research process. And with these goals in mind, the Open Air initiative builds the Open Air Research Graph. And the graph is a big collection of metadata records describing entities of the research life cycle, so publications, data sets, organizations, projects. And all these entities are linked to each other and form, as the name says, a graph. So OpenAIRE builds the graph by aggregating metadata records from many different sources worldwide, sources that are trusted and used by scientists. We include Crossref, DataCite, ORCID. We have a big network of institutional and thematic repositories, and also information about the projects that come from the databases of the different funders. And we have Cardex for the European Commission projects, but also other national funding agencies. Next slide, please. So as you can see in this slide, the OpenAIRE Research Graph is not simply the results of collecting metadata from 1,000 sources. So without going into much details, OpenAIRE also detect duplicate records. So for example, the preprint and the published version of an article appear as two versions of the same publication in the final graph. We also apply enrichment algorithms. We run them on the metadata, but also on the full text of open access publications. And the goal is to enrich the graph with information like links and properties that are not explicitly available in the metadata, but that can be mined from the full text and derived from other information. Eventually, the graph is made available via the different OpenAIRE portals, including Explore, OpenAIRE EU, and the EnerMaps Gateway that you will see in the next phase of this workshop. We also analyze the graph, and we offer statistics for the funders, national agencies via the OpenAIRE Monitor and the Open Science Observatory. So here on the right, you can see some numbers. So more than 120 million publications, millions of data sets. So the graph is pretty big. Next slide, please. So the OpenAIRE graph keeps track of all these different aspects of research, and also different aspects and practices of open science. So the goal of open science is to have reproducible research, a transparent evaluation of the process, and attempts to go beyond the publication-centric reward policies that are in place. But at the same time, open science also pushes to maximize the innovation potential and the impact to society of the research. So on the left of this slide, you can see some of the main open science practices. And the EnerMaps gateway that you will see in one of the next parts of the workshop addresses all of them with specific features. So for example, you can use it to find open repositories where you can deposit any type of research products in a way that they are open. You can, via the gateway, add links between the research products. So for example, you can say that a publication is supplemented by a data set and that the software has been funded by this project, for example. And you can also use services that are made available via the European Open Science Cloud. Like we have the integration with the annotation service of EUDAT, for example. Then, of course, we want to facilitate the reuse of data, and this is very relevant for the goals of EnerMaps. So you will see that there is a dedicated panel where you can search for curated data sets of EnerMaps from within the gateway. Next slide, please. So one of the concerns that researchers typically have on open science and the practices that you saw in the previous slide, this concern relate to the current rewarding system, which still evaluate researcher based on the impact factors of the journals they published in. I would like to stress that changes are happening at the policy level, and not only thanks to the UNESCO recommendation, but also thanks to DORA, which is the Declaration on Research Assessment. And its basic principles are that research should be assessed for its merits and not based on the impact factors of the journals, and that we should give value to all types of research outputs. So not only articles, but also data sets, software, protocols, standards, and in order to have an omnicomprehensive view of the research outputs. So DORA has been endorsed already by several organizations, and so you can find a list on the DORA website. And in addition, also funders embraced its principles. So you can see that these principles are also applied in the next calls for the European Research Council, for example. So this is a very important information. So this tells you that the things are really changing at different levels. Next slide, please. So if you still have some doubts on open science, want to learn more, or need support, do not hesitate to go to the OpenAir portal, so www.openair.eu. You can find several guides, and some guides specific for EnerMaps may also be found on the EnerMaps wiki and in the gateway. But you can also contact your national open access desk. This is a person which is who is an expert in open science, open access, that is typically part of the library or repository of universities, and they can really give you support in order to apply the open science practices in your daily research activity. And this concludes my presentation. Thank you.
Thank you very much, Alessia. I don't know if there are any questions from the audience. No? Okay, so let's go on. Yes, there is one. You can use this. Don't worry.
Thank you. We have a question online. The open science diagram from UNESCO should, I believe, include open data standards as standalone entity, particularly those standards concerning data semantics, because many of these are currently proprietary. So I don't know what exactly is the question here. That's Robbie Morrison. If you could maybe request what you would like to do or to ask.
No, it's a comment, and it's very relevant. In fact, when we talk about open science, we don't talk only about open data, but also about fair data. And in order for data to be fair, they must be interoperable. And if the standards used for these data sets are not open, interoperability is very, very hard to reach. So thank you, Robbie, for this note. Thank you very much.
Thank you, Alessia, for explaining further this aspect. So good afternoon, everyone. I'm Giulia Conforto from eThink, and I'm gonna guide you through the training program that we have designed for EnerMaps. The first aspect of the way we designed our training program is that it is overarching. It's going to be easy to understand for the participants. It's very interactive and it's tailored on user needs. Overarching in the sense that it does cover the gateway. So it teaches how to find and reuse scientific publications, data, and research results. It covers the data visualization tool. So during that part of the training, you can learn how to use the calculation modules, their inputs and their outputs. And then it covers open science. It helps you discover the potential of open science, both through the gateway, the tool, and the curated data sets that are behind both of the two layers. It is also very much user-oriented because we do identify three main target groups among our potential users. The first is science and research, and what we have designed for this target group is that energy professionals in research, be them universities or other research centers and organizations, academia and students, could be the main target group for EnerMaps. Then other users could come from the industry, and among those professionals in energy utilities, energy companies, especially in the field of renewables, energy managers and energy planners, and then also users from the public administration, such as officers in public administrations operating within the energy sector, as well as their consultants. Now, this that we're going to have today will be a training. Every training is different because in every training we do cover different aspects of the project. The next upcoming ones will be the On Sustainability Conference in Granada at the end of January and the World Sustainable Energy Days in Wels, Austria at the beginning of March, which I believe is going to be postponed to the beginning of April. That's very fresh news. So if there are no questions on the training program, I would go on with the demo of the gateway. So we enter into the very practical aspect of today's training. If you want to connect to the gateway, please type beta.enermaps.openair.eu and be aware that this is the beta version. The release version will be enermaps.openair.eu. You can access that as well, but it doesn't provide the latest updates. And for the attendees in person, the Wi-Fi network is Enlit Gemini and the password is 7EW9CETU. So we said that just a second, there are some comments in the, okay, perfect. Just let me know if there are any questions. We said that the EnerMaps deliverables, EnerMaps as a project has been built on this double layer concept. One layer is the research community dashboard, the gateway, which is characterized by a high coverage of research results, but a very low selectivity. So it is a single entry point where a user can search by keyword, by type of publication, or by type of research outcome, such as data set or software, for instance, and can cover a wide variety of items. And the second layer is the data management tool, the visualization tool, which instead has a very selective approach, a very selective approach with a low coverage. It is a visualization tool for geolocalized data that shows the 50 curated data sets. Now, the 50 curated data sets that have been selected throughout the EnerMaps project can also be reached through the gateway. So there is a section dedicated to data sets, and a user can see the metadata there and then can click on the thumbnail and be brought to the data visualization tool. So, okay. Now, this is just a screenshot of the gateway. Soon we're going to go through a demo. The gateway is a portal to search open access publications, as we said, research outcomes and data set and software. It is currently being fine-tuned to show only results related to energy without the interference of non-energy relevant results, which is often one of the issues, because when searching for keywords such as energy or energy cell, you name it, there are so many keywords that bring about results from biology related publications, chemistry, physics, and they are not always strictly related to the field of energy. So this is the gray noise that we are currently reducing further and further. And it's of course it's a process of increasing approximation. Now, the way the EnerMaps Gateway helps you practice open science is that it helps you and your community to address the different challenges of scholarly communication. So you can discover new literature and data among the wide variety of publications and data and data sets with this selection of only energy relevant results. It reduces, therefore, the dispersion of research products. It helps users to report their project outputs because users can sign up and use their login area to link their own project to the research outputs on the gateway. And it also fosters a collaborative curation of the record of research in the energy field, supporting the integration with domain-specific services. Now, these are the terms that the different items that can be found on the gateway. A user can run a research by keywords, can browse through projects, can explore a number of data sets and data sources, and there is also a link to the Zenodo communities. Another link is between the different products in OpenAir, on Crossref, or the other content providers to the community that you can do with a single entry or also in a bulk. Now, this is a slide where I will stay a minute because these are our main resources addresses. So enermaps.eu is the project website. The gateway has these two addresses for the official and the beta version, let's say the release and the beta version. The EnerMaps visualization tool currently in a beta version is at lab.edapp.ch/EnerMaps. And then the GitHub repository for the project is github.com/enermaps/enermaps, and the wiki is enermaps-wiki.herokup.com/English. Maybe Clemence, could I ask you to copy paste these links in the chat? Perfect, because we're going to use them later as we're going through the demo of the gateway and the calculation modules. The attendees can do the same. Do we have time for a demo of the gateway, or should we move on straight to the? Can we? Perfect. Then as I'm sharing my screen, I'm just gonna move to not this one. Okay, so here I just loaded the page beta.enermaps.openair.eu. As you can see, the gateway looks very much like the OpenAir gateway. If you are familiar with that, if you're not familiar with that, let's go through it. So the main search bar, it's quite self-intuitive, is where you can run your research by keyword. And you can already select if the research is gonna be run through all the research outcomes or only selectively through projects or by content providers. There is an advanced search button to the right that helps showing all the filters that can be applied to the search. And scrolling a bit down, well, the summary is just a brief introduction to the gateway. The publication is the section dedicated to publications. Then you have a section for research data, for software, for other research, and for the featured datasets. The featured datasets ideally will be 50. Currently, they are 36 because we are in the process of verifying details about the licensing of these datasets that, although are open access, it is to be clarified in which terms and with which agreement we can publish them on the EnerMaps website. More and more complication for the open science. So for instance, if you open one of the data sets, there is a short description of the data set. There is a link to the proprietary website where the data set is hosted. There is a section for the single identifiers, and there is a link to the EnerMaps tool, which opens a second page straight to the tool that you will see in a second with that database already visualized and a few details about the database. Going back to the main page, let's run, for instance, a very simple research. So for instance, energy cell with a little bit of patience. That's the beauty of
that's the demo effect. That's the demo effect.
Maybe I can try again, or we can try on the official website.
Yes,
Okay.
try on the other one. Yes.
Perfect. Also, the internet is not particularly strong in this room where we are streaming from. So here we were saying energy cell. Because I'm thinking, for instance, you're looking for fuel cells, but energy and cells is one of those results that can give you so many, it is one of those keywords that can give you so many results that are not energy related. So it is interesting. Here, we're finding 2,295 results. So we can select if we want to look at publication, research data, software, or other research products. Let's say we select publications. There is an option to choose the year of publication, the last year, last 5 years, last 10 years, or a custom range. There is a filter by funder, a filter by type of publication. So if it is an article, a preprint, a report, the language, of course, if it is connected to a specific community, there's a filter by content provider and by country. And what happens when and of course you can choose how many results to show per page and how to sort them. And if we open one of the results, we have the date of publication and the publisher straight away, the DOE number, to the right, a number of links where the publication is accessible, the keywords, And on the reference page, these are the references. Alessia, are these the references of this publication that are quoted in this publication?
Yes, these are the reference list in this publication.
Okay.
And if this publication was also linked to a dataset or a software, you would also see a dedicated tab here, so that you can basically navigate from the publication to the datasets to the software, exploiting all the links that the publication has.
Let me then go back and show what happens with the results that are softwares. For instance, EY Calc, energy yield calculator for multi-junction solar modules with realistic irradiance data and textured interfaces. It was published earlier this year by Zenodo. There is an abstract and the DOI number and the keywords and the links. And for some of them, you say that there is a dedicated section.
Yes, in this case, we don't have the link to the publication, so it's only the software that is available on Zenodo.
Okay, perfect. Or maybe I just selected one of the only software that doesn't have a link to his own publication, because the problem is that
not all software have a link to a publication, so it's it's normal.
Yes, because we depend a lot on the metadata that is provided with any of the publications and the items, right, Alessia?
Yes, exactly.
Yes, so for a brief demo of the gateway, that was about it. I'm going to go back to the presentation and I'm going to leave the floor to Markus Hummel, who is going to guide us through the data visualization tools. Thank you.
Thank you, Julia. I see there is a question. No, no question. Okay. Yes. So yes, good afternoon also from my side. Yeah, and I will use the next 10 minutes in order to introduce you to data visualization and open access tools. Actually, not only open access, they are really open source tools, which means that you're not only able to just access them, but you're also able to just take them and do whatever you want to do with it. So further develop them, change them as you want. Actually, I'm going to show you two tools. First is called the EnerMaps tool. Second is then the EnerMaps tool. Actually, as we have already heard, EnerMaps is a further development of hotmaps. And yes, so that's also the reason why I show you the two tools, so that you can see what is the difference and how is the additionality. Hotmaps actually is a tool that was designed to support public authorities, energy agencies, and planners in strategic heating and cooling planning. And it consists of a database, a toolbox, and a wiki. The database, it consists open source data that is needed for heating cooling planning. Part of it geographically explicit, part of it not. The part that is geographically explicit you can access via the toolbox. The toolbox then visualizes that data and also provides calculation modules with which you can analyze different solutions for heating, cooling, supply and demand. And then we have the wiki. The wiki actually provides information, background information on the database, on the toolbox, and also guidelines how to use it. Here, just for seeing how this toolbox is meant to work, it's actually a collection of a number of calculation modules, and those work together, or you can use them together in order to come up with solutions for a region that you have selected. And as you can see, there is a number of calculation modules where you first start to analyze the demand side, and then you analyze different supply side options. Yeah, and now here you find a couple of links that give you further information. I will just use some minutes in order to show you the tool. You can access it on your own via www.hotmaps.eu. So it's a web service actually. And as we have also already heard, we have a little bit of poor internet connection here in the room where we are. Yes, so actually it's a visualization tool. So you have a map and you can work on the map here. You have actually, as I said, a number of data that is available here in order to visualize it, also to analyze it. Here, for example, different renewable potentials, industry data, building related data. And as soon as you have selected a region, you can also see indicators. I will just show you, you can also go to a certain place. Maybe as we are in Milan, let's go to Gorgonzola. So here we are actually, and we can then select, we can then select the region. So this is Gorgonzola, I will select it, try to select it. And now we can have calculations on this region with demand side modules, supply side modules, just to see how this works. Here we can check the very quickly the district heating potential for Gorgonzola. Actually 85%, according to this very rough calculation, Gorgonzola might be interesting for a district heating system. So this is a very quick intro. So you have, of course, a lot of different calculation modules, as you have seen, in order to analyze heating and cooling demand and supply. Now, the EnerMaps tool, as I have said, is a further development of it, not only focusing on heating and cooling, and also then providing different calculation modules. Here again is to remind you of the Wi-Fi network and the password if you want to right now check that. And here is also the link to the tool then. So that's actually the how we call it. It's the EDMT, the EnerMaps Data Management Tool. And as you can see, it's also a visualization tool. So you have again a map. You have again different data sets. That's the 50 data sets, or still not 50 data sets that have been selected and provided via EnerMaps. And here you can then also search within the data sets. So for example, the heat demand map, you can here have a heat demand map. So it's now loading. Actually, it's also a heat demand density map for Europe, an estimated heat demand map, or you can also have, for example, the European settlement map. So you can also select this one. You can also select the zone, and then you have up here the calculation modules. Currently, we have 2 calculation modules in the tool. One is the heat learn. I will just now say some more words about it, and also a heat demand analysis module. So the platform actually is currently still under development. And what you can expect is to have 5 calculation modules to come up. It's actually one of them, the heat learn module, is actually to have the option to get a quick estimation of the heat demand density of buildings in a selected area based on a regression model of measured data on heat demand in the region of Geneva in Switzerland. We have another calculation module to quickly estimate heating and cooling saving potentials in buildings of a certain type, so buildings of a certain archetype in a defined location. So here it's actually the Tabula Data on different renovation options for different building types is used together with heat estimation of the change of heating degree days and cooling degree days. Then we have a calculation module to estimate the change of heating degree days and cooling degree days based on scenarios for change of climate according to climate scenarios. Then we have another module, DHXPOT. It's actually to quickly estimate the economic potential for district heating in larger regions based on a limitation of the heat distribution costs. And then we also have one calculation module to quickly come up with a load duration or with a load profile for buildings in a certain location or certain buildings in a certain location for space heating demand. Yes, and now I will hand over to Pietro Zambelli to give a little bit more insights to selected calculation modules. Yes, the floor is yours.
So, hello everyone. I'm just going to share the screen. Okay. Okay. Hopefully you can see my screen. So I just close my stuff here. Okay. So our previous colleagues already presented the platform and how it's working. So I would like to go a bit more inside to some calculation models that are still not published on the platform because we are finalizing the modules and the integration process, but they will be there soon. And to give a bit overview of what is the aim, what we are doing with these calculation modules as well. And to conclude also, I would like to show how to build your own calculation module. So which are the main process, let's say. Of course, I have a few minutes, so we will not code really on this, but I will provide some insight and information about the process and where to find where you can find other information. So for each calculation module and in general also for the platform, we have a wiki dedicated, and inside this wiki we have the description for each calculation module. So one of the calculation modules that I was involved with was the one on the heating and cooling scenarios. For this calculation module, we basically use the Cardex data set. The Cardex is a consortium of people that aim to scale downscale the climate scenarios from all the researcher working on the climate and climate change, and they are downscaling to specific area, and in particular, since this is a European project, we focused on the Euro Cardex. So it's the European this downscale to the European area, let's say, of the future climate scenarios. And just to give you an overview for the people that do not know the Cardex data, these Cardex data are providing the average, the minimum and the maximum daily temperature from 1948 to 2100. And we have the daily data, and also the Cardex is providing this information based on different scenarios, so under different conditions, and using different, so we have 5 different conditions that are considered on the Cardex dataset, where we have more than, we have 10 different climatic, global climatic models, so that they are modeling the whole world climate condition. And then for the European area, we have 14 regional climate models that were used to downscale it to the European condition. Overall, this produce a relevant number of raster maps that we are using with the minimum and maximum temperature. They are more than 10 million of raster at the moment that we are processing. And we process this map to compute the heating degree days, the cooling degree days in a way that we can see trends and assess which would be how the heating and cooling demand will change in the future. To do so, we keep, let's say, an extra variable. So we use the minimum and maximum temperature provided by the Cardex, but we also integrate a base temperature. The base temperature is useful because based on the activity and based on also on the characteristics of the buildings, we may have different base temperature to compute the heating degree days and cooling degree days. So we keep it as a variable that the user can select the from the tool. So just to go through the tool, this is on my local machine. So we have less data, but yeah, so let's select Milan since we are in Milan. And okay. Oh, I forgot to upload the data set. Sorry. So here we have the calculation module with the refurbish rate. That is the other one. And may I move this? Yes. And here you have the heating degree days and cooling degree days module, where we can select the reference here that we want to select, the scenarios that we aim to see, and we also have the base temperature for the heating and base temperature for the cooling, and then we can compute and extract, which so far we are just extracting some indicators of the heating degree days, the overall in the overall period, and we will also produce the trends, so how these values change over the time. This is the first calculation module that I want to present today, and the second one is the refurbish calculation module. So this second calculation module is combining the information extract from Cardex to get the heating and cooling degree days with the U values from that we took from Tabula that is covering the whole EU, considering different building archetype. And then we use the population as a proxy to assess the square meter of certain building typology in a certain area, and then based on this information we can assess which are the impact of our refurbish in a certain area for a certain building epoch of construction. So just to give a bit of insight here, this is the Tabula data set, where for each building you can have some building characteristics and performance using the let's say existing the status quo, let's say, for that specific building typology, and the performance that you might reach with the user refurbishment of the buildings and with the advanced refurbishment of the same building. So we use, say, the population data set for the LAU2, so at the municipality level, and yes, and So coming back to the platform here. So again, we can select an area, it's already select, and we can select a period and execute. So it might take a while the first time that I'm using, and then it will provide the savings for each building epoch, and the apartment block in that case was selected, but you can select multifamily or single or terrace houses. And again, the time of your interest and the percentage of refurbished that you are foreseeing, for that area. So these are the calculation modules that are now into the integration phase to the platform. And before leaving, I would like, I still have 5 minutes. Yes. Okay, then that's fine. Good. So okay, I have more than 10 minutes, so I think I would like to show a bit how the code is structured. So all the development has been, I mean, is on the GitHub under EnerMap, and the whole platform is under the EnerMap repository. The development is, I mean, public since the beginning, so it was always public. And here you can find the code. Okay, so the code, the platform is using Docker Compose system. So just to understand a bit, so we use Git for tracking the changes in the code, and we use Docker Compose to make the platform available on your machine, and then we develop all the calculation modules, but all the platform as well, and all the integration tool as well has been developed so far in Python, just to let you know. Furthermore, if you look a bit at the code, we have 3 different Docker Compose. So we have the Docker Compose for the whole platform, so to manage the front end, the database, etc. We have the Docker Compose specifically developed for the database to integrate the data set and from different resources and update the resources as well. And then we have the one dedicated for the documentation to show the wiki page, etc. So this is the general structure. All the documentation for the developers are in a README file. So here you have the general README file that provide all the commands to build and run the system on your computer as well. And then you have specific README file for each directory where it's relevant. So for instance, this is for the API, so you can have again all the instruction to play with API on your machine. And so to build a calculation module, all the calculation module are inside the directory CM. So here you can see a list of the calculation modules that are available here. Where we have an example empty, an example multiply calculation module. The empty is the calculation module where people that want to start their own calculation module can just copy that directory and start modifying the code. The multiply is again, another example of the calculation module that is just multiplied by a factor a raster layer. Okay, so So this is, if you want to create a calculation model, then you can just copy one of these two and start playing with the code. So here I'm comparing the two folders, the empty and the multiply calculation module. So each calculation module have a Docker file where basically you define how to build your calculation module. So which software you need, what must be installed, and what have to be performed before running the calculation module worker. And this is also opening the possibility to use other languages that are different from Python in general. It is sufficient that they expose the same API, okay? And so what is provided by the project is, however, the Python API interface. Then we have the input layer file. That is a file where you can specify the calculation modules can be applied only to a subset of the data available on the EnerMaps platform. So, for instance, the empty calculation module is available for all the calculation module. Instead, the multiply can be applied only to the raster. Perhaps it's a bit small. Let's see. Ah, okay. And then we have the requirements. These again are standard Python way to define which library and package you want to use for the service that you're developing. And then we have this important JSON file where you can define the interface. So to define the interface, basically we use this JSON form schema where you can define your JSON, and this will get data better form. Sorry, input. Create form. Yes. So here you have just so let's have a look on the JSON. Here you have properties, and we have one field that is species supported with an enum with different kind of species that are available in this. And so when we create the interface, let's say, we have the species that are available, that are defined in the JSON file, and extra information like the description and the title that will be displayed for each task. So just to come back for this example here, for the multiplication, we just need a factor to use that is of type number, that is that one. And then we can set a default value for the specific parameters. So yes, then we have the setup config is just to define the linting of your folder if you need to set up the maximum length of the code and this kind of style issue. And then we have, of course, the test where you can write your own test to verify that what you want to do is actually what the calculation module is doing. And to conclude, the worker, that is the entry point for the calculation module, where you can basically set up the calculation module name, and then define the function that is performing the task that you want to do. So in this case, it's just multiplying the raster value by using the factor and return the result. So yes, as said, the code is with the example as well is already on GitHub. If something is not clear, of course, feel free to open an issue on the repository. So as you see, that there are some activities and exchange that are already going on there. So yes, I'm open if there are any question to answer. No. Okay. Yeah. Okay, stop sharing. Okay. Do you want to speak? Yes. Perhaps Jakob, do you want to share something to keep close?
Well, I think we went from really high up to from the high level to the line of code. So I hope that we could offer everyone something that you were looking for in terms of the platform. And as always, when you do a better presentation, some things don't work as planned. So thank you for sticking with us. We'll try to do it better next time. Of course, when we do this under stress on the first demo, that some of those effects can happen, and hopefully the next time we'll be able to show you a bit more as also the development and fine tuning goes on. So feel free to ask any questions now. We're there for listening. Okay, I see one open question. I guess the hotmaps processing pipeline depends strongly on the underlying data semantics. Is there a process for developing and agreeing on things like data definitions, underlying ontologies, and so forth among a wider analytical community? I guess that is an answer where I would ask also you, Pietro, to if you can complete, if you have an input on that one. Just be aware that so far your microphone is muted if you want to say something, Pietro. That's a question coming from online from Robbie Morrison. Do you want to answer? Or shall I go ahead with the first shot on the answer?
Can you hear us, Jakob, now?
Yes.
Yes, no, maybe you can start. Actually, I have to read the question and understand it accordingly. Yeah. Maybe you can put your comment.
So I'll just do it a little bit more in a bit wider way. The way I understand the question is like, did we for hotmaps and then also for EnerMaps define our own way of handling data? Or is there a wider analytical community behind it that is working the same way, so that that can be maybe transposed from one project to another? That's a little bit how I would summarize the question. And as a first answer, I'd say I think this, especially this process of calculation model online in web platforms, is at the time when we started hotmaps was something fairly new. Where we try to separate the pure IT work and give the community, this time the energy heat planning community, a specific platform under which they can, under relative simple ways, do the development and hand in a calculation module yourself. So there are some basics made, but it's still it is project dependent and yeah. It's something that we simplified and further simplified for EnerMaps, so that it can be more easily generalized, I think. But maybe somebody wants to comment now from the room. I don't know if my answer was clear. I'll be happy to.
Yes, I could also give a little bit. Actually, I mean, I think it depends a lot on the data that you have for a certain location. That's one thing. So I think the data that you have will always be individual. Same goes for the questions that might be the most important at the location. So both is individual. At the same time, you need analytical frameworks to tackle those questions and work with the data. So the aim for us for hotmaps, and I think similarly for EnerMaps, is to set up a frame where we can use I mean, we had to define a certain data framework that we work with. That's always the case if you have an analytical tool that you work with. So we try to come up with something very simple in case of hot maps. And of course, I mean, in the more you advance then in the tools, the more individual data can be used then. So now what you have to do is to shape or transform your individual data to the structures that are usable with the tools. And I think the more the tools are advanced, the more tools, then additional tools you have in order to transform the data. I don't know if that was really.
Yes, if I may, we also work a bit on the ontologies and semantic of the data on the to better improve, let's say, or contribute also on this aspect. We are aware of the open energy ontologies that are also developed on GitHub as well. On one end, what is defined already, I think, is very technical and complex somehow. On the other hand, what we try was to integrate the simplified version to the schema.org organization to raise discussion on these ontologies for the energy classification of the data as well. So yes, I think this point is really relevant. But yeah, I don't have an answer exactly on how to integrate in a definitive form, let's say, this issue, but is something that we are in the process still, I would say.
Yeah, and maybe to also add on it, I think it's a development from on several parts of the parts of the coin, let's say, as Pietro has said. So we are trying to come up with ideas how this can be structured, or how such data can be structured. And I think also this will then influence the way the data is generated. So there are a lot of initiatives going on to derive more measured and, let's say, automatically generated data. And I think it's the more data you have, the more you develop those structures based on the data that you currently have. Then you try to measure and come up with more data, and the more you can then adapt the analytical frameworks to those structures. So I think it's a stepwise procedure. More questions?
Or did we answer this question the other way around? Maybe Robbie Morrison is still online. And if you have a follow-up question, feel free to shoot it to us. Well, if this is not the case, we see there the answer. Okay, hopefully that helped exactly. As you could see from the answers, we're trying to adapt this the data semantics really to the energy related problems, which needs some construction that is really adapted to the problems that we face. However, I think we're not on a community that has the habit of developing necessarily all the ontologies up to the end that somebody from computer science would bring in rather. So I guess there's an interface on which we still should work and discuss. From my side, we're a bit sorry that we're running a bit late and we just had time for one real question. So for this, I would then conclude. So because it's important to keep the timing, some people of the consortium are still available. and feel free to discuss informally at Enlit on topics and questions that you have in mind. Feel free to reach out to us over email or LinkedIn, or shoot us an issue or a question on GitHub when something is not working like you expect it to. We are really closely following that, and we're looking forward to the exchanges that we can have with you, and maybe the solutions that EnerMaps can bring to problems that you're facing. So from that side, really thank you very much. I will wish you a great afternoon, and that's it, I think, from my side.
Much also here at Enlit for your participation. Yeah, I don't know, anything to announce from our side still? No?
No, but probably that this training will be published as the proceedings of the event. So you can find it on YouTube on the EnerMaps playlist published by Revolve and eThink, and it will be later in the Learning Center of our website. Thank you everyone for your attention and interaction, and enjoy the rest of your afternoon.